All right, with number 3, let's first find these values algebraically. So let's start with the vertex. We know we have A, B, and C. So we know that the x value is negative b. So the opposite of b is positive 4 over 2 times 2, which is 1. Now to find the y value, I'm going to substitute in y. 2 times 1 squared minus 4 times 1 plus 7. Well, 2 times 1 squared is 2 minus 4 plus 7. When I do this, I get that y equals 5. So my vertex happens to be at 1, 5. Since my x squared value is positive, I know that my parabola would be opening upward, which would make this a minimum. And then the third thing is to find the zeros. So I can try factoring, and you'll see you'll run into some issues here. So let's go straight to the idea of using the quadratic formula. So I know that x would equal, well, opposite of b would be positive 4 plus or minus the square root of negative 4 squared minus 4 times 2 times 7. That's a and c all over 2 times 2. So this is 4 plus or minus the square root. Well, negative 4 times negative 4 is positive 16 minus 4 times 2 times 7 ends up being minus 56 all over 4. So when I do this, I end up with 4 plus or minus the square root of negative 40 over 4. Now, a square root of negative 40 should be like sending off some alarm bells in your head that, wait a minute, you can't take the square root of a negative, which means that there's no real solutions to this problem. Because when I take the square root of negative 40, that's going to give me a complex number, or what you may call an imaginary number. Now, how can we verify this by graphing? So let's look at the graph of this. We have y equals 2x squared minus 4x plus 7. Now look what happens to the graph. I'm going to pull the graph down. It never crosses the x-axis, which is why there's no real solution. But what it does do is it has a vertex, which we found to be 1, 5. So because it doesn't cross the x-axis, there's no real solution.